Inspection method. What we do in inspection method, we do common inspection about certain familiar Z-transform pairs to get their respective inverse Z-transforms. It is very easy to find the inverse Z-transform. In other words, we can say that we just look to the Z-transform pairs, and by inspection we are able to get their inverse Z-transforms. It is exactly like you just check something and do common inspection about it, and then you come to know about this thing, that how it has been made, how we're gonna use it, where we're gonna use it. It's just a common inspection. Example number 1. Find the inverse Z-transform of x of z equals to z over z minus 1 by doing inspection method where z modulus is greater than 1. Look, it is a Z-transform x of z equals to z over z minus 1. We want to find the inverse Z-transform. It is in frequency domain. We want to shift it in the time domain. So to do so, we are using inspection method, where its region of convergence is that z modulus must be greater than 1. This is the region of convergence for this Z-transform, z over z minus 1. The z must be greater than 1. When you look to the region of convergence, which says that z modulus is greater than 1, which means that it is a right-sided sequence. It is the Z-transform of a right-sided sequence, because in a right-sided sequence, z modulus is greater than this value. If it is 1, it should be greater than 1. If it is 2, it should be greater than 2. If it is a, it should be greater than a. And also z shouldn't be 1, because 1 minus 1 equals to 0. You will have z over 0, which is an undefined situation. That's what we call it the inspection method. We did inspection and we got that it is a right-sided sequence by checking the region of convergence. So from here I can say that its time domain will be x of n equals to 1 to the n. 1 to the n will be the signal in time domain. But let's go through the process. We know that the given Z-transform is x of z equals to z over z minus 1. And also we know about the standard result where the Z-transform of a to the n equals to 1 over 1 minus a times z to the negative 1, which equals to z over z minus a, where z modulus must be greater than a. Look, it is not a simple a to the n, which equals to 1 over 1 minus a times z to the negative 1. When you take the Z-transform of a to the n, it equals to 1 over 1 minus a times z to the negative 1. And then when you make z to the negative 1 equals to 1 over z, you will get a over z. After taking LCM at the end, you will get z over z minus a. So z over z minus a is the Z-transform of a to the n, which is according to the standard result. If you forgot what is standard result, we have a complete section about the standard results. So a to the n equals to z over z minus a, where the region of convergence says that z modulus must be greater than a. It is for the right-sided sequence, because a is positive. If a is negative, it will be left-sided sequence. So apply the exact logic here. What is my a? What is my a here? My a is 1. So can I write 1 to the n? Because look, a to the n equals to z over z minus a. My a is 1 here. So for the a, I'm going to plug in 1 here. Therefore, I can write that z over z minus 1 equals to 1 to the n. 1 to the n is the signal in time domain. Now the signal is in time domain 1 to the n. As I said, for the a, I have 1. So I just want to plug in 1 here for the a. 1 to the n equals to z over z minus 1. We just applied this standard result, which implies that x of n equals to 1 to the n. There we got the time domain of the signal. X of n equals to 1 to the n. Here the signal is in time domain. So we applied the inverse Z-transform by using the inspection method to shift the signal from frequency domain into time domain. Now the frequency is in time domain, x of n. X of n is the notation of the time domain. So x of n equals to 1 to the n. 1 to the n is my signal in time domain. As I told you earlier that we do common inspection in this method. First we did inspection from the region of convergence that it is a right-sided sequence. Look, 1 to the n is a right-sided sequence. If we have negative 1, then it will be a left-sided sequence. But since it is positive 1, so it is a right-sided sequence that we checked from the common inspection by checking the region of convergence. And then we did another inspection from the standard result. According to the standard result, a to the n equals to z over z minus a. So from here we did a common inspection that look, my a is 1 here. So I just want to plug in 1 for the a. And there we got the signal, 1 to the n. And finally we got success that x of n equals to 1 to the n. There we got the signal in time domain, x of n equals to 1 to the n. If you find the z transform of x of n equals to 1 to the n, you will get back the same x of z equals to z over z minus 1. If you apply the z transform, you will get back x of z equals to z over z minus 1. But since the z transform is given, therefore we applied inverse z transform. We did the other way around. We come in counterclockwise to shift the signal from frequency domain into time domain. It is in frequency domain, it is in time domain. And that's what we do in inverse z transform.